Hey, hello everyone. Are you guys able to hear me? I'll just quickly put a poll question. Are you all able to hear me? Yes or a no? Yes, friends. Please, can you reply to that poll question? Okay, wonderful. And how many people do we have? I see that there are one, two, three, four. Okay. All right, there are a good number of people. Just give me quick 1 minute while we get into this. Just a quick minute. I should share the screen in quick minute. I'll be sharing my screen in a minute. Okay, so I'll be sharing my screen now. Friends, I request you all to confirm whether you are able to see my screen or not. Is my screen visible? Wonderful. Okay, so let's get started with the discussion of aviation analytics. Sure, yesterday you guys would have learned about a few aviation industry analytics solutions that exist. And today I wish to speak about a few more. But before I speak about these, the one key thing that everyone should remember, especially when it comes to domain specific analytics, is that you need to be aware of something called as value chain. Okay, what is this entire value chain of aviation? Right from start until the end, what are the various things that happen in aviation industry? Can a few of you all quickly name? What do you think happens in aviation? Yeah, you can randomly keep giving me the answers. What are the various things that happen from start until end when it comes to aviation industry? Within an aviation industry, what happens? Yeah, feel free, friends. If someone wants to start an aviation company, what do they need? Come on. Yeah. Okay. Kazim says, all right, people will book flights. This is one thing which exists. And company, okay, assume that you already have AirAsia, which is operational. Now what happens? Booking flights is one thing, yes, certainly. And come on, friends. You can do much better. You show ads to the customers, okay. Advertisements would be shown to customers. And what happens? Only Kazim is replying. All the other folks, come on. This is not done. Did you not travel in flight ever? Think from that. What happens usually? You book a flight, then what happens? Okay, maybe you might want to do competitor analysis. And okay, not enough competitors, okay. And all right. So I think I need to motivate you all. Yeah, price the ticket. So pricing analytics comes into picture. Friends, if you're wondering on, hey, why is this guy asking questions? Do you know what? Aviation analytics market supposedly will be worth $3 billion by 2025. What market? Not aviation market. Aviation analytics will be worth how much? It'll be worth $3 billion by 2025. Okay, and that is what markets and markets. There is a company which does research, markets and markets. You can explore that. That is what they have to say. That aviation analytics will be worth $25. That is 11.5% increase from 2020 to 2025. 11% increase. And a lot of aviation companies are establishing themselves in the space of specific analytics zones. And they want to build a profitable business and customer-centric aviation industry. When it comes to aviation, sure, you book flights. And do you think any aviation company can have thousands of flights? Not really. How many can they have? They can have maybe, 10, 20, 30, 40, 100, depending on their global footprint, etc. But certainly it cannot have infinite flights because there is a cost associated with that. And when you're booking flights, another thing that happens is, how soon can I fill the seats? Say an aviation company opens its tickets. I mean, you can book the flight tickets 90 days beforehand. So if say this is the travel date, and say they're giving you 90 days. I mean, this is 90 days from the travel date. Usually, how many people do you think book their flights upfront 90 days before? Very small proportion of people. As in how it nears the travel date, the proportion of tickets which are booked increases. And maybe it will reach 100%, or maybe it will reach only 80% of tickets. That means 80% of seats will be full. So how do I ensure that another 20% is also full? That's a business strategy. But then you as a data scientist or an AI expert can at least predict and say that, do you know what? Occupancy percentage or the load factor, that is number of seats which will be booked, would be maybe 70%. Say you forecasted that number of seats that will be booked is 80%, and maybe your organization, your aviation company has a goal that you need to fill at least 80% to maybe break even. To break even, maybe you need to fill at least 80% of the seats. But your model is saying that only 70% of the seats will be full. Maybe your marketing team pitches in and says that, hey, how do I reach 80%? The prediction clearly says that only 70% of the seats will be full. Maybe they'll give some discount. Maybe they'll run some offer just to ensure that the occupancy percentage increases. Oh, they can give a whole lot of discount and fill until 100%. Isn't that true? Yes, but then as and how the number of passengers increase, what will happen? Fuel consumption increases. And one of our friends is saying that fuel price analytics. Sure. You look at what is the price of the fuel now, what will be the price of fuel, for the next 1 month. Because aircrafts use different fuel, not our, petrol or diesel. And when it comes to this analytics, people also look at what are the various countries which a specific flight, okay, which a specific flight is going to travel to. In which country is the price cheapest? Can I ensure that the route that is planned is in such a way that it goes to a specific location where the fuel is the cheapest and then moves along a different location such that it is the shortest path? Can we actually do this? Sure, we can. Okay, so one is, if you already have flights, you can predict what will be the load factor or occupancy percentage. Another thing is you can forecast what will be the price of the fuel, not just in the home country of the flight, but across the various countries. Kerosene is not used, Kazim. Okay. Flights have different fuel. It's expensive than your petrol or diesel for that case. Kerosene is out of picture. Okay. And you need to find out the shortest path such that first your flight takes your passengers, goes to a specific country where the fuel price is the least, fill the fuel, then travel. Is it only the fuel price that drives? Not really. In a specific country, maybe the fuel price is the least, but when your flight lands, there is a cost that you need to pay to the airport. There is a cost that you need to pay for number of hours that you're going to park your flight. It could be in the hangar, or it could be near the aero bridge where passengers board or deboard. And you have to pay to the airport for the ground handling staff. People who, unload the luggage or load the luggage. They need to be paid. For n number of hours, you'll be charged. Then when you take off, for taxiing to the runway and then flying, they charge. You need to pay as an aviation company to air traffic controller of this airport, or if there is ATC here, it is going to probably cover a radius of 50 kilometers or 100 kilometers. Suppose that this ATC would hand over to another ATC. Once its radius is finished, another ATC would take it up. They are like regulating the traffic on the air. You need to pay them to avoid collisions. Of course you have to, there is no other go. You need to, as an analytics expert, consider all these pricing factors and then decide the shortest path, which is also going to give, which is also going to cost you the least. So your objective will be to minimize the cost. And this is when you already have flights. What if you need to procure flights? How many flights do I need to procure? From where do I need to procure? Okay, so these are a few questions which can also be addressed using analytics. I'm going to take one simple, of course, covering all this in maybe another 30 minutes would not be viable option. However, I'll take one specific use case and ensure that I cover that. Just give me a minute while where is it? Yep. I turned off the sharing because I want to open a specific slide for you guys and then explain you about Analytics. Yeah, I think it's here. Yeah, I got the business problem. I need the Excel sheet here. Of course, there are multiple airline aviation use cases, but I'm going to touch upon only a few. Come on. Okay. I think I found it. So, one moment while I share the screen with you guys. Okay, I think I figured out. Okay, let me share my screen now, and you can view it, look at the specific use case. Say this is a business problem that we need to solve. Okay, hope you guys are able to see my screen. And the goal of a specific aviation company is to expand the operations. They want to go global, maybe, or they want to expand across the country, maybe. So, TBA Airlines is a small regional company that specializes in short flights in small airplanes. Okay, short distance flights. They have small airplanes. Maybe they have ATRs. And the company has been doing well and has decided to expand its operations. The basic issue facing management is whether to purchase more small airplanes to add some new short flights or start moving into the national market by purchasing large airplanes, or do they need to do both? Should they purchase new short flights, or should they purchase some large airplanes, or should they purchase both? And how many airplanes of each type should be purchased so as to maximize their total net annual profit? This is a question that we need to answer. And here is the data which is provided. So you have small airplane and large airplane, and the net annual profit per airplane is $1 million. Here you have $5 million for large airplane. That's the amount of profit that you make per annum if you buy a large or a small. And the purchase cost per airplane is given to you. One small airplane is going to cost you $5 million, and one large airplane is going to cost you $50 million. And you have a capital of $100 million. And the maximum purchase quantity is 2 small airplanes. And there is no limit as such on the maximum number of large airplanes that can be purchased. Okay, all right. Now, assume that there is no constraint as such. Assume that this last statement is not given. If it is not given, what would you do, friends? Would you purchase small airplanes or large airplanes given you have $100 million? Yeah. Which airplane would you purchase, and how many of those would you purchase? Think and answer, please. Take 2 minutes time, but think and you will be in a position to answer. Come on, friends. What would you purchase? Would you purchase small airplanes or large airplanes? You would obviously want to purchase, you have $100 million of money, which you have. So you would obviously purchase what? 2 large airplanes. If you purchase 2 large airplanes, one airplane is going to cost you $15 million. So you'll get 2 large airplanes with 100 million. If you have 2 large airplanes, on one plane you get $5 million as annual profit. And on 2, how many do you get? 2 into $5 million. So you get $10 million as your profit. Versus for $100 million, how many small airplanes would you get? You have $5 million. One flight airplane is going to cost you $5 million. So you can purchase how many small airplanes? Oh, you can purchase 20. Right? Sorry, my bad. It's not large airplanes that you'll go with, small airplanes, right? Because per airplane here is giving you $1 million as profit. So you'll get in total $20 million if you purchase small airplanes. If you purchase large airplanes, you get $10 million. Where would you spend your money? Obviously, you'll spend your money purchasing small airplanes. This is if there are no constraints levied on you. But your business is putting a constraint on you. And what is that constraint? They are saying that, you know what? The maximum that you can purchase is only 2 small airplanes. Because maybe they want to expand at a national level. They want to expand to other parts of the country. Okay. So whenever you are given the data, you have to first look at the data and identify 3 key things. What are those 3 things? One is decision variables. What is the decision that you need to take? You need to take a decision on how many flights or how many airplanes you need to purchase. So let me say S is equal to number of small airplanes to purchase. And let me say L equal to number of large airplanes to purchase. All right. So these are the decisions. You need to decide how many small and how many large do I need to purchase. And what is your objective? All right, you will do this, but what is your objective? That's called as objective function. Your objective is to maximize the profits. Now, I want more profits. Obviously, any business exists to maximize the profits. And how much profits do you get if you purchase small airplane? $1 million into number of small airplanes plus $5 million per airplane. And so multiply it with number of large airplanes. This is what you want to maximize. So this can be written as S plus 5L, where S is number of small airplanes and L is number of large airplanes, because 5 is because it gives you $5 million as profit. After these two, you need to list down constraints. What are the business constraints? One is capital, the amount of money that you have to purchase the flights or airplanes. So that is your total investment. Investment capital, which is available. This is equivalent to 5S, which is $5 million for one small airplane, plus it's going to cost you $50 million. The amount that you spend on this should be less than or equal to $100 million. For $5 million into number of small airplanes plus $50 million into number of large airplanes should always be less than or equal to 100. Are there any other constraints here? Sure, there are. What is that other constraint? Number of small airplanes purchased. Number of small planes purchased. This is number of small airplanes, S is given as S. Should be less than or equal to 2. That's the constraint which is levied. And also one final very important constraint is non-negativity constraint. And what does non-negativity constraint say? It says that number of small airplanes and number of large airplanes that you purchase should be at least 1 or 0. I would say it should be greater than or equal to 0, not at least 1. It should be at least 0. It cannot be negative. Either you purchase something or you don't purchase. But you can certainly not purchase 0. These are the constraints that are given to you. Now, if you guys want to do it along with me, you can, or rather, I mean, that amount of time won't be available, I believe. Look at this. I'll try to help you understand. For this, you need solver. You need to go to, I believe, file. You need to go to options and add-ins. Under add-ins, you have Excel add-ins. You need to click on Go. And here you have solver add-in. You need to select this. Put a check mark here and click on OK. And then what happens is, under data, you'll see an option called solver. This option gets enabled. And Excel solver is more than sufficient for you. to address this issue. Okay, now please pay attention here. Small airplane, large airplane. What is the unit profit? It's already given here. Small airplanes give you $1 million as profit. Large airplanes give you $5 million. That 1 and 5 is listed down here. And capital. How much money would you spend? $5 million on small airplane and $50 million on large airplane. So you have 5 million and 50 million. And the total amount that you're going to spend should be less than or equal to 100 because you're given $100 million. Now here, there's a formula which is written down. It is sum product of capital per unit purchase. Capital per unit purchase is cell number C8. Okay, here it is C8 and D8. And number purchased. Number purchased is C12 and D12. So number of small airplanes that you purchase multiplied by $5 million per small airplane plus some product plus number of large airplanes purchased into cost of each large airplane, which is 50. When you multiply this with this plus this into this, you get this. And this value should always be less than or equal to 100 because you're given only $100 million. No, unfortunately, recorded video won't be provided, but you can go ahead with your project meeting and yeah, that's how it is. Or I'll conclude it. When do you have project meeting, Kazi? Anyways, I'm going to conclude this in the next 5-10 minutes and then we'll wind it up. Okay, and maximum number of airplanes that you can have is 2. That's a constraint. And what do we need to minimize? We want to minimize what do we want to maximize? The profits. How do you get the profit? Unit profit multiplied by the number purchased. So number of small airplanes multiplied by 1 plus number of large airplanes multiplied by 5. That should be maximum. This, you want to maximize the profits. So all you need to do is go to your solver and select total profit in your objective. Okay, you need to select that. I'll just select this part. What do you want to do? You want to maximize this profit. And what are the decisions? Decisions are how many small and how many large airplanes you purchase. So I would just delete whatever is there. I'll select this and select these values because I want to change that. And what are the constraints which are available? The capital spent, the amount that you spend. Let me remove this. Let me add. So the amount that you spend should be less than or equal to the amount which is available. You say, okay, it comes up there. And small airplanes should be less than or equal to 2. So let me delete that. Let me add it. The number of small airplanes should be less than or equal to 2. And then you have a third constraint. And that constraint is these two cannot be negative. So these should be integer values. Integers, not decimals. And then simply select simplex linear programming, select solve, click on OK, and there you go. You have the answer. If this constraint is levied on you, All you can do is purchase 2 large airplanes, and when you do that, you get a profit of $10 million. While this is the simplest of the use case, these use cases can get very complicated and manually you cannot solve it. Okay, so these are a lot of interesting use cases that you can solve. There are a bunch of other things, but in the interest of time, I'll stop here. And yep, if you want to know more about our program, I'll quickly go here and then 360 digit MG. That's our company. And here, when you go to domain analytics, you have aviation analytics course. And sure, you can explore the bunch of use cases that you're going to experience. Regression, classification, new routes identification, machine learning and forecasting, data mining and customer loyalty points, so on and so forth. Okay, and you can reach out to us. Our contact details would be available at the end of the page if you want to know more about this program. Yeah, until then, thank you so much and have a good day. Thank you all, friends. Bye for now.